1, go. Alright, relative motion. This is our intro video. We're getting our feet wet. This is a little scary, but it ain't that bad. It's not that bad. It's relative motion. I mean, come on. It's really, it's concept, right? We can figure it out. It's a little concept, you know. But here we go. So, relative motion is just keeping an open mind about, like, how something is moving based on something else's movement, right? So normally we're standing there watching things move, and it is what it is, however it's moving, right? But now we're taking into consideration, what if the observer, the watcher, is also moving, right? How does that affect them? What if they're moving towards the object that's moving? What if they're moving away? How, you know, relative motion, right? So let's look at some of this stuff. Let's see. Clear learning targets. We're just going to go over a few of these. Just a few. No big deal. You know, just a couple. One or two. The vector. Vector is just like velocity. It's a magnitude, like a number with a direction. That's it. Scalar, just like you stand on a scale, it gives you a number, right? So it's raw, short and sweet. Okay, resultant is like, it's sort of like, what's the word I'm thinking of? Displacement. Where it's like if you start here, and you go this way, and then you go this way, right? You walk north and you walk to the right, east. The resultant is the starting point to the ending point. Boop, right there. So it's sort of like displacement, right? So you're going to do all this stuff, vector, scalar, you know, it ain't hard. We're going to breeze through some of this stuff. Okay, so when you're drawing, let's talk about adding vectors and scalars, just real quick. So sometimes it'll say, like, let's just go to the page. Yeah, let's go to the page. We're flipping around fast. So this page, and I want to say I have a breakdown of this. Maybe I do, maybe I don't. I don't know. So we see that the A, so looking at A, and all this here has to do with all this other stuff, right? So you'll answer these with this up here, right? So A, the vector is 3 up. 1, 2, 3 up, right? So that's the vector, right? A is the same vector as H because it's 3 up. If we were just talking raw magnitude, A has the same magnitude as H, but it also has the same magnitude as C because it's 3. Magnitude just cares about number, right? Vector cares about number and direction, right? So for instance, if it says, hey, let's do A plus B, we'd go 1, 2, 3 up, and then plus B, that means we just add B normally, 1, 2 to the right. Now if they said A minus B, we'd go 1, 2, 3 up, because there's A, but minus means opposite direction, so we'd go 1, 2 to the left, right? So that's sort of what it is down here when you do that stuff. So remember, vectors have a direction and a number. Magnitudes are just a number, just like scalar, right? It's just a number. So we did this. We kind of sort of talked about drawing vectors already. Draw the first vector. It's a vector because they actually tell us north, right? So 5 miles north. Draw the second vector. So we drew 5 miles north and then we did 5 miles east. Remember, this is like walking stuff. So let's say if they give you this and they give you this, right? Think about logically walking, right? You wouldn't connect these vectors like this. Notice my arrows are pointing at each other? Because that would mean I walked north, and then what, I teleported over here and walked to the left? That doesn't make any sense. What you would do, so let's X that out. What you would do is you'd go up, and then you'd connect them logically as a walking path, like this. Now that makes sense, because it's walking, right? If we were to draw the resultant, it would just be from beginning to the end. Doop. There's my result, right? So there you go. So that's that. There'd be no resultant if they overlapped, right? So if you went here and then you went here, there's no resultant because there's a direct overlap. Doesn't mean you can't cross if you need to cross, but you can't overlap like that. So that's that. I think I go through a lot of these. I'm not going to sort of go through all of these. Trajectory, frame of reference. Ooh, I definitely go through this page. But all this is like, yo, how is it going to look during different frames of reference? So for instance, just real quick, if I toss a coin up, my perspective, the coin goes up and it goes down, more or less, right? It might go a little bit, but it's up and down. If I'm on a bus going 100 miles an hour and somebody's on the sidewalk and I toss my coin up on the bus and then it comes back down, my perspective is still up and down. But the sidewalk's perspective is I toss it up because they're not moving, remember, and then I'm going past them 100 miles an hour. Really fast bus, right? From the sidewalk's perspective, it goes up and it goes a little ways and then it comes down, right? So just keep that in mind. It depends on the perspective. I think I talk about this. I'll do one of these real quick, and I have a video on here where I break down a little bit more. So something to keep in mind. When it says relative to the blah, 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 whatever the word after the blah, blah, blah is, motion relative to the, that's you. That's where you're at. So, for instance, this one says relative to the car. So, you're in the car. So, if we look at, let's say the bird relative to the car. Where am I at? I'm in the car, right? In this case, I'll be in the car. So, the motion of the bird relative to the car, in other words, my perspective of how fast the bird's going in which direction. So, relative to the car, the bird is going to be going 32 plus 17, what is that, 9? 49 meters per second west. So then the question is, okay, well, why is it 49? Well, if they're going at each other, are they going to seem faster or slower? They're probably going to seem faster, right? So from my perspective from the car, this is going to seem like it's going this plus my speed. There you go. So let's do another one. Let's do the bird relative to the boat. So where am I? If relative to the boat means I'm in the boat, right? So if the bird's going 17 west and the boat's going 12 west, if it's relative to the boat, that means from my perspective in the boat, the bird is going 5 meters per second west. Because we're both going the same direction, the bird's going faster, right? So it's going to be passing me. But from my perspective, I'm already going 12. It's only going to be passing me slowly, right? So about 5 meters per second. So that's not bad. Check the video out. I kind of break down more. And once you guys finish this page, let me know. You're welcome. You're free to check it. I'll give you the key. Check them over. Make sure you get it. The next page is the same. Nothing going on here crazy. Just keep in mind, read this. Because some people just look and they don't read. Read this because that tells you what's going on. Because some people are moving on this bus while the bus is moving. So you got to think like a few levels deep, right? Has it already been 7 minutes? Oh, wow. Time flies. That's it. Lab. I kind of went over the lab, quickly in the intro, but, not the intro, the instructions. Just get on Canvas. That'll give you the clickable links for this. Watch the short videos and kind of go through it. You'll get it. If you guys got any questions, let me know. It's a pretty easy unit. Just make sure you watch videos and ask questions. Goodbye.